So this is 2009 question 3 part B, I think. Right, we've got a plane is inclined at an angle of 60 degrees to the horizontal. A particle is projected up the plane with initial speed of u at an angle of theta. So I'll just start drawing that in. So we'll draw in the plane first. So 60 degrees is quite a high angle. It's actually higher than that, but I'll just leave it like that for the diagram. And we'll go here as the horizontal. So this here is 60 degrees. Next thing that we know is that a particle is projected up the plane with an initial speed u at an angle of theta to the inclined plane. So we'll draw this in green maybe. So it gets projected up this plane here. I'll actually undo that, it's a bit too high. Up this plane here like that at an angle of theta. The plane of projection is vertical and contains a line of greatest slope. So that means that the projection, it's up, it's going to be going up this way here. The particle strikes the plane at right angles. So I'll just try to draw that in. So if this goes up here, it has to strike the plane so that this is at right angles to here. So this final velocity here, I'll do that with an arrow because it doesn't look good there. I'll use it in red as well. So the velocity when it strikes the plane is at right angles. Okay, so what does that mean? Now we'll have a little just to look through this first. With all these problems, what you want to do is first off you write out what ux, uy, ax, ay, vx, vy. It's a range problem as well, so we're going to be using sx and sy as well. First off ux, so we know that's angle theta. From the other problems we should be able to kind of maybe speed up on these a little bit. So we know that it's the adjacent of that, so it's going to be u cos theta. Uy will be u sine theta. Ax will be, so the incline is 60, and it's g minus g sine of 60. Ay is minus g cos of 60. Vx then is, v is u plus at. Let's put that in just so we have it. U plus at. S is equal to ut plus a half at squared. So I'll fill in what these are. So we've got u cos theta minus g. We'll put in what sine 60 is straight away here. And if you have your log tables, it will give it to you in surd form. I think if I remember correctly, it's root 3 over 2 actually. Just if you could check it there. And for Vy will be minus u sine theta, and then it'll be minus a half g. Is that the sine of 60? Would you mind just checking that just for a second? Okay. Then this is, we have, I'll just put them probably here. So that's root 3 over 2g, and this is minus 1/2 g. So the displacement in the x direction then will be ut, which is ux, which is u cos theta, t minus 1/2 a t squared, so it's root 3 over 2 t squared. Sy is equal to u cos, or u sine theta, t minus 1/2, there should be a g there, 1/2 g t squared. So I won't simplify them, I'll just leave them as they are for the moment. Now let me just think about this for 1 second here. So if we know this angle here, it's got a component in that direction and it's got a y component in this direction as well. For it to hit this perpendicular to the plane, and we'll just have a little think about this. So if it's travelling directly perpendicular to the plane here, there is something we can tell about the velocity. So now, at that moment in time, it doesn't have the Vx, the final velocity in the x direction, has to be 0. Now, I might have misled you when I gave you the question, I think. So I think this must be how it's done, is because strikes it travelling perfectly perpendicular, the whole lot of the velocity is in the y direction. There's 0 velocity in the x direction. Now, that would make it, I think that's probably where the problems were with it. So if we have, from this, Vx has to be equal to 0. Now, so if Vx is equal to 0, we know u cos theta minus g root 3 over 2 is equal to 0. So we can get an expression for theta out of this. We want everything in terms of, so we want to show that the angle, that the range on the inclined plane is 4 over root 3 u squared. I might just pause this for a second and we'll come back. So there's a small mistake in these two equations here. I should have a t there for Vx, a t there for Vy, and then this is our t here for when Vx is equal to 0, because if it strikes the plane perpendicularly, it only has got a component in the Vy direction. Now, using this equation here, we can get an expression for t. So if I bring the u cos theta, we'd have minus g root 3 over 2. T is equal to minus u cos theta. So divide both sides by minus g root 3 over 2, and we get t will be equal to 2u cos theta over g root 3 g. Now that's one expression for time at the moment of impact. We know that's the case. It's equal to that.